All righty. Another day, another dollar. Another day, another dollar, right? Okay, folks. So today we are going to learn about inherit. Oh, that's also. Whoopsie daisies. Whoopsie daisies. All right. So we're learning about inheritance. Inheritance in programming. It's a very important concept. Basically, we can. Well, let's read about it. Let's read about it. I just covered a bit of it in Solidity, and what it is we can build contracts that do some base level of functionality, and then we can inherit kind of the things from that contract to build a more niche down data model. So over here on the right, we have human, which is being instantiated, I imagine, by, or the archer class is built on top of the human class. I imagine is roughly what we're going to be doing here. I haven't pre-read anything, so I don't know what we're actually going to be doing. But basically, we can build these generic classes like an animal, right? But then within animals, you can actually build upon it like a dog or a cat. That would be like a different class, and then within the dog class, you could actually build like your dog, like Max or something, who's an animal, who's a dog, who's named Max. So it's kind of like this like, let's build the most umbrella generic thing first, and then we'll niche down a bit and continue such. Let's read. Let's do the reading part. I got the reading glasses on. It's time to do what we do. Okay, so inheritance. We've made it to the holy grail of object-oriented programming. Inheritance. Inheritance is the defining trait of object-oriented programming. Non-OOP languages like Go, boring, no, just kidding, and Rust provide encapsulation and abstraction features as almost every language does. Inheritance, on the other hand, tends to be unique to class-based languages like Python, Java, Ruby, JavaScript, TypeScript. What is inheritance? Inheritance allows one class, aka the child class, to inherit the properties and methods of another class, the parent class, right? So that was that example. We have the parent class of animals. So what do all animals have? Like all mammal things, right? Like warm blood, right? That's something consistent across all animals. But then, boom, if we have a child class of that parent class, we have a dog, which is different from a cat, but they both are still animals. So that's kind of how we're building out the data structure of this. Okay, so let's continue reading. What is inheritance? Boom. Oh, I just read that. This is powerful. It's a powerful feature because it avoids us from writing the same code twice. Don't repeat yourself. Okay, so in Python, one class can inherit another class from using the following syntax. So it looks like we build the class, and then we build the second class we want, and then we just pass in the parent class to say, hey, this is what it's starting with, by the way. Now, I wonder if we could do comma and inherit multiple things or not. In Python, I'm sure we can. Okay, so our assignment here looks like super inits. We can pass in the level of legs here for the cow. Very interesting, though, how you can't say self number of legs, but I guess maybe that makes sense. Okay, so in Age of Dragons, all of the archers in the game are humans, though not all humans are necessarily archers. So we have all humans, and then archers is a subclass of it. So the thing all humans have in common is that they need a name. So the human class is taking the name logic. So we have a name up here. Boom, boom, boom. Great. And now we need to write an archer class. Archers are humans and therefore need a name. But we don't want to rewrite all that logic and code. Don't do that. We don't want to do that. Let's just inherit the human class. So that's what they do here. They have the archer class inheriting the human class. And it looks like a net. We need to probably do some sort of super. I didn't read the full instructions, but I bet this is roughly what we're going to do. So we'll see here. We'll see. Maybe self.boom, number of arrows. This self.name equals name. Let's just go ahead and run it. Let's not even read. We passed some of them, failed some of them. Okay, so it looks like we want private classes for number of arrows. So let's try this. Sweet. Because we didn't even have to read the whole thing. We just run it and got it this morning. Just getting it done. Okay, so that roughly makes sense. So the super.init is just invoking the initialization from the human class. So basically it's just coming up here. We're just passing in. So this super.init is just focused at this one, and we're just passing in the name deal. Same thing over here, right? So we have the super init. It's just passing in 4 for the number of legs for the animal. that we're building. So it's just an easy way for us to declare these archer classes as one thing. So then when we build an archer, so maybe we'll build the guy legless, right? I think that's how you spell legless. We could just pass in the archer, say legless, and number of arrows, I don't know, maybe like 16, and boom, that would build them. So, okay, let's move on. When should I use an inheritance? Inheritance is a powerful tool, but it's a really bad idea to try to overuse it. Inheritance should only be used when every instance of the child class can also be considered the same type as the parent class. When a child class, this is good to learn, by the way. When a child class inherits from a parent, it inherits everything, all the disease, all the genetics, all the bad. No, I'm just kidding. So if you only want to share some functionality, inheritance probably isn't the best answer. In some cases, you would probably just want to share some functions or maybe make a new parent class that both classes can inherit from. So all cats are animals, but not all animals are cats. So this is the overlap here, it looks like. Okay, so we don't want to build too generic of a class. We still want it to kind of scope down a bit, is what I'm hearing from it, right? So it makes sense for animals to inherit from plants. Not really, to be honest. Sweet, we got it. Makes sense for cats to inherit from animals. That's true. That does make sense. Okay, so animals and plants might inherit from a new class called organisms. Yeah, that seems about right. Okay, so that's just the larger scope of like animals, plants. We have like organisms that kind of connects the two, I suppose. And then we can even scope up further of like things on Earth, So you could always go up in scope, and you can always go down in scope too, right? When you're talking about these concepts and ideas, it's important to understand how they work, because the programming language is like very, I want to say, conceptually aligns with how the brain processes information. I don't know if that's true or not. I've never like deeply studied the brain, but when you have these like empty buckets, if you will, right? Like it's just an empty bucket of data, right? Is the class. And you're saying, I'm going to define this empty bucket of data to be this. And then you can niche down that empty bucket of data that's now a full bucket of data that says, hey, this is a class of human. And within that, I want to define my buddy Doug, like, so you're niching down. I don't know. I think that's maybe a stretch on how the brain and programming languages process information. Is probably why they were built the way they are, but I haven't studied the brain enough to make a full statement on it. So anyway, let's read. So inheritance hierarchy. There's no limit on how deeply we can just nest and inherit it. For example, cat can inherit an animal that inherits a living thing. Oh, we just talked about this. This is great. This is perfect. So that said, we should always be careful that each time we inherit from a base class, the child is strict subset of the parents. You should never think of yourself a mild child class needs to couple both my parents' methods, not these other ones, and still decide to inherit from that parent. Don't do that. It's bad juju. Okay, so the game designers have decided to add a new unit in the game called crossbowman. A crossbowman is always an archer, but not all archers are crossbowmen. Crossbowmen have several arrows, but I'm saying that funny. Crossbowman. Crossbowman. It's a crossbowman. Okay, but they do have an additional method called triple shot. So use arrow self dot boom boom boom. Method to archer. It should remove the number of arrows every time it's used, right? So use arrows method in the archer class. Let's go to this. So we have arrows, and then we could actually say, steal this bit of private class here. Say -1, I suppose, or maybe minus the number of arrows. And okay, so that's step one. It should remove number of arrows. If there aren't enough arrows to remove, it should say, so let's say, so if self.number of arrows is less than, now we want to raise an exception of not enough arrows. Sir, what are you doing? Okay, so not enough arrows. Bow. You can't be shooting that bow, sir. You got no arrows. So that's number one. So the crossbowman's class, number two, in the constructor should call the parent's constructor. So we'll say super dot init. I think that's all we need to do, right? The crossman's bow triple shot should take 3 arrows. Okay, so super init, and let's see, crossbowman's triple shot. Looks like we're going to add some stuff here. So let's say triple shot, boom. Actually, don't think we need to do that because the use arrows may be inheriting the use arrows class. Potentially, let's see if it is. So the crossbowman's triple shot method takes a target as a parameter and returns blank was shot by. So returns it or prints it, right? Let's see. So target was, can I just do an F string here? Will this work? Target was shot by 3 crossbow bolts. Great. Where bolt is the name of the human of the target. Okay, so let's try that. No. Okay. Failed. Okay, so we have, I needed to pass the name and number of arrows here. So we have name, self, number of arrows, boom, boom, boom. Where is the thing broken? So creating an archer named Isaac with 4 arrows, creating a crossbowman with 0 bolts. My guy. Maybe we'll do the same logic here. Say if, well, no, we don't need that. Okay. Why did we fail? Let's take a look. Use arrows. Oh, it's because of my lovely JavaScript syntax that I do far too often. Okay, we also have to use the arrows, of course. So self.number of arrows, self.use arrows. That's what we needed. So target equals target get name. Turns out to be we needed to learn some things here. Folks. This is great. This is just fantastic. Okay, so let me read this. Boom. Okay, so target.get name. So is target being passed in as human? Is that what I'm understanding here? So this is, let's reread this. So target as a parameter is the name of the human that was shot. Got it. Okay, so that's the key word there that I missed, these 2 bits. So we're using the arrows and the arrows. It sounds like Oreos and arrows or something. But okay, so in the target.get name, that's how we invoke these functions. Is obviously we have access to these things. I just did not recognize that. So hopefully that passes. Still not passing here. Wonder why. What's going on? Oh, duh. Gotta update the target to the target name. I guess I suppose we could do this, right? Not have to worry about it. Sweet. Okay, so inheritance hierarchy quiz. Imagine dog inherits from canine, which inherits from animal. The dog class's super function calls the constructor of the blank class. So dog inherits from canine, which inherits from animal. I would imagine the super only goes up 1 level. I would imagine. So that would be the canine. How many levels deep can a hierarchy be? Infinite, right? So multiple children, just meaning how many classes can we build? We could build unlimited. We could as many as you need. So multiple children. I want multiple children. I want a whole litter of them, like a whole bunch of little critters running around. It'd be so fun, just having a big old farm and a bunch of little critters. Golly, what a good old time, right? So, okay, so multiple children. So far, we've worked with linear class inheritance. Asterisk note, before we leave off that topic of me wanting a whole bunch of critters and a whole bunch of money with it, you know what I mean? So you could actually have fun with them. Super important part. Okay, so far, we've worked with linear class inheritance. In reality, inheritance structures often form trees, not lines. A class can have as many direct child classes as the programmer wants. Assignment. The hero class is provided to you. In this assignment, you'll be writing the archer class that inherits from the hero class. Okay, so boom, we are building the archer class here. Pulls in this hero class right here. It looks like we need to initialize some of these things. So looks like it initializes the the name and the health, but we need to maybe add this arrows deal. So, and then next you'll be writing the wizard class. Fun. Okay, so archer should inherit from hero, which it does right here. Boom, boom. Archer should set up the hero's name and health, set up a private number of arrows, which we've gone ahead and done. That can be passed in as a third parameter to the constructor. So I don't think we need to do anything else. We just need to do that. And then create a shoot method that takes a target hero as an input. So this is going to be a hero. If there are no arrows left, raise an exception. Not enough arrows. Hey there, guy. What are you doing? There's no arrows. So if, let's say, almost did the old JavaScript syntax. Okay, so if number of arrows equals 0, you could raise the exception. Not enough arrows. Boom. Otherwise, remove an arrow and deal 10 damage to the target. Okay, so we will say self dot number of arrows here minus equals 1 to subtract 1. And then we also need to take damage for the target. So we could say target, because they are a hero class, take damage of 1. Do we need to, 10, not 1. Okay, hopefully redemption here for first take Drake. First take Drake. First take Drake. Let's go. You guys don't understand. I live for this. I live for this. Okay, so multiple children. Assignment. Let's extend our hero class. Let's do it. Why not? Let's extend it by adding a second class called Wizard. Okay, so they built it for us. Kind of selfish, but whatever. So Wizard heroes are more powerful than archer heroes. They cast spells at other heroes instead of shooting them. Fireball. And casting does 25 damage instead of 10. Also costs 25 mana. Okay, so fulfill the following requirements. Wizard should inherit from hero. Okay, so we do that already here. So the wizard class inherits from the hero class. Wizard should set up all these things. So self.name equals name. Self.health equals health. Self.mana, right? We just initialize it to equal the mana. I don't think anything's private. Except for mana, private here. So we'll hit the double underscore. That variable can be passed in as a third parameter to the constructor. So boom, here we go. We probably actually, now that I look at it, we probably just want to do this. Just to get the superclass of the hero. We don't actually want to make the health and name inside the wizard class. We could, I suppose, but if we're given the method, might as well use it for the parent class, and we are, so let's use it. Create a cast method that takes a target hero as input, so cast here. If there's not enough mana left, okay, so we need at least 25 mana, I imagine. So let's say, if self.mana is less than 25, we need to raise exception. Not enough mana. Else we need to remove self.mana 25. Cool. One pass, one fail. And we need to deal damage to the target. So we will say target, my deal here, target take damage of, looks like it's 25. Sweet. All right, so inheritance inheritance trees are often often more deep than wide, I would imagine. This is saying wide than deep. Okay, so then that's probably the answer. So I was thinking it would be like this, but it looks like more wide than deep. Cool. So multiple children quiz. A class must have at least blank children at the most to be children. A class must have at least 0 children. Yeah, it doesn't have to have children, but it must have 0 children and at most infinite. So I'll go with that one. Sweet. Cruising right along. Okay, so dragons. In Age of Dragons, there are orcs, humans, goblins, dragons, etc. All of these different creatures are called units. At the moment, the only specific to a unit is that it has a position on the game map. Here we go. We have y equals, or x equals 0, y1. So that's one of the points. And then x equals 2. Or x2 equals 2 and y2 equals 2. So dragons, a specific type of unit, can breathe fire in a large area, dealing damage to any units. So this is kind of cool. So this is how I imagine they are, what's it called? Dealing damage. Side note, I was just reading this. Our game map is just a Cartesian plane. I don't know if they just meant to say graph. Is that what a Cartesian plane? This is what a Cartesian plane is the whole time. It's a graph. I haven't green economics, right? So this is, had no idea it was called a Cartesian plane. Had no idea the whole time. Zero idea. Seen a million of them, did a million test answers on them. No idea it was called a Cartesian plane. Who would have thought? I'm gonna flex that. That's just a big thing. Oh, you mean you wanted to Cartesian plane it? Oh, you mean graph it? You mean Cartesian plane it? So super stoked. It's gonna be a good time. Cartesian planing things, It's a mansplaining, but Cartesian planing, Cartesian splaining. Okay, so complete the units in area method and the dragons breathe fire method. in area, this method has 4 parameters, x1, y1, x2, y2. So where x1 and y1 make up the bottom left and x2 make up the top right, as we see here. So that's the bottom left coordinate, the top right coordinate. Okay, so use the unit's position, x and y, to determine if it's inside of the rectangle. If so, return true. Otherwise, return false. Okay, so we need to breathe fire. Oh, in area. Boom. Okay, so that's step uno. This is going to be good. We're Cartesian planing already, so this is perfect. So okay, so breathe fire. This method, well, let's maybe knock this one out first. Okay, so in area, okay, so we have x1 and x2 in position x and y. Okay, so let me think about what we're going to be given. So I need to build a square effectively. So x1 and y1, right, equals our first tuple, right? So this is chord 1, right, or point 1, and then obviously this would be point 2, or maybe not so obviously. Maybe this isn't the right track, maybe it is. But okay, so these are our coordinates. So let's think this through, because we need to build out the area of the square. So in order to determine if we're in the area, we first have to build out the area. So x1, let's just run through some dummy math real quick. So if we're given 0 and 1, so just as we were on the topic on the Cartesian plane, so we'd have 0 and 1 in one corner, and then we'd have, let's say, 1 and 2 in the top right corner. So how do we define the area of a square again? Guys, this is going to be humbling here, but how to define the area of a square by coordinates, right? That's the trick here. That's the trick. So we have an area, obviously we have, here we go. So we of course we find the width and height based on the coordinates. Okay, so boom. I just need a refresher, guys. It's been a long time since I've done Cartesian planing. Okay. Relax. Don't come for me. Don't kill me. Okay, so what we can do is we actually don't need to do all this jibber jab. What we do need to do is take x2 subtracted by x1, right? So x2 minus x1, right, would give us the width. So this would be rough width, right? And then we could have the height, which would be y2 minus y1. Okay, so this, let's play it out again. So in our dummy example, the coordinates were 0, 1, and 1 and 2. Okay, so we have x1, so it'd be 1 minus 0, right? And then y2, we have 2 minus 1. So we'd have a width of 1 and a height of 1. So we'd say 1 times 1 equals 1. So that's the rough area. Oh, but hold on. So that just defines the area. We need to now see if the person's in it. So maybe I'm doing way too much. Maybe we can literally just check. Guys, I actually completely messed this up. I recognize now. I recognize Cartesian planing threw me off. I think all we need to do is just see if am I in here or am I out here? I think that's all we're doing, right? So I just need to check if my position of x and y is less than this point or greater than this point and less than this point and greater than this point and less than this point. I think that's actually it. So both things have to be true. So let's say in x, we'll say this third approach at this point, which I'll accept. I'll gladly accept. The third time is the charm. Okay, so let's say, so if x1, right? Let's see. So in x1, so position x needs to be greater than or equal to x1, and position x needs to be less than or equal to x2, right? So what I'm finding here is if I'm greater, we're just going to look at the x-axis, right, which is this guy. So either my position x is greater than x1, so it's at 0, and it needs to be somewhere less than x2. So x2 is over here. So boom, we need to be somewhere in between there. So we can either be there or less than, I believe. I think it's inclusive. If not, we'll just change the equal signs. So that's number one. So in x area, right? And then in y, it's the same deal. So position y, though. Oh, we need to change these to self position y, but we'll do that in a sec. believe, so self position y is greater than or equal to y1, so right here, or less than or equal to y2. So that, I believe, is our things. And then we need to return, and this will actually return true and false for us, I believe. So if we just do in x and in y, boom. That's it, folks. That's us. That's us all day. That's gotta be. That's gotta be, you know? So let's change all these things real quick. Cool. Oh boy. Okay, so that's, I believe, the mathematicals here. If we really want to get real ignorant on our developer friends, we could just, you know, throw in a half thing, you know, make sure to throw off the readability here. I'll just do this, right? I think that'll do. I think that'll do for the area bits. So we got there, took a little wrestling, a little wrestling and wrestling, a little Cartesian planing, and let's do the brief fire. Okay, so this method can cause the dragon to breathe fire, a swath of fire in the target area. The target area is centered at XY. Area stretches over the fire range in both directions exclusively. For each unit, exclusively is important. That's what is going to define our equal sign or not. For each unit in the units array, append that unit to a list. Is this not one of our challenges? This is just one of them. This is just great. What I mean, great. It's not even a challenge. Just great. Just do some Cartesian planning. Not even a challenge. Okay, so it append that unit to a list if the unit is within that blast. Okay, so a little bit disclear on that, but let's think about it. So we have self XY, so that's the coordinate in the middle, so 1, 1 right here. And the units, I believe, or that's not the thing, that's the fire range. Okay, so I thought the units fire range, got them confused for a sec there.